Hi, everybody. So today's just going to be a quick practice on compound probability. We've done this topic before, but I figured we might as well spend a little bit more time on it just to get some better practice and a little bit more comfortable with this topic. So, just to refresh, we've got two types of events. We've got independent and dependent events that occur. So, in this example, we're going to be looking at these chips, and they all have different colors, different letters, and there are point values under each letter. So, for our first one, it says you draw a tile, put it back, then draw another tile. What is the probability of getting a blue and then a yellow tile? So first, we're going to look at it as we're going to get a blue tile. So we have two blue tiles. So I have two out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tiles. And then I want to put that tile back. So if I chose this one, for instance, then it would have been out, but I'm putting it back into the pile. And that's why it becomes an independent event because my second event, it doesn't matter what I got as my probability for the first time. So for my second fraction, I'm still going to have 11 options. And now I want a yellow tile. So now I have 4 options out of a total of 11. With compound probability, we always multiply the fractions. So this turns into 8 out of 121. You always want to simplify the fraction as much as you can. In this case, that's already simplified. For our next one, I'm going to jump over to the dependent version of the same exact problem. So for number 2, same scenario, we want to choose first a blue one and then a yellow one, but the fact is that now we're going to keep it. So for my blue tile, I'm still starting off with 2 out of 11 options. So let's say I chose this one. That's the one that I ended up getting. Now, in order for me to get a yellow tile, I still have 4 yellow options, but I only have 10 tiles to choose from because this blue one is no longer one of my options in that second round. So that's why with dependent events, it all depends on how many you chose the first round or how many were taken back. So this becomes 8 out of 110, which simplifies to 4 out of 55. Okay, so for number 3, again, this is an independent event. So you draw a tile, put it back, and then draw another tile. What's the probability of getting an R and then a B? So how many R's do we have? Actually, I'm going to erase this piece right here. So to get an R, we have one option. So 1 out of a total of 11. And then we put it back. So I'm going to erase that. And now I want a B. I've got 2 options here out of a total of 11. So it becomes 2 out of 121, and that's it. That can't be simplified. For the dependent version of this, we want to choose an R. So again, we have 1 out of 11 options. And now that one option is no longer there because we're going to keep it. So that means we have 10 options to choose from, and we want to select a B. And again, we have 2 options for B. Multiply straight across becomes 2 out of 110, which simplifies to 1 out of 55. All right, last example, 2 versions. So for the independent version of this, now we want to find the probability of getting a tile worth 1 point. So let's look at how many we have worth 1 point. 1, 2, 3, 4, 5, 6, 7 of them. So 7 out of 11 are worth 1 point, and then worth more than 2 points. So that remains this one, this one, this one, and this one. So that's 1, 2, 3, 4 of them. Multiply straight across, 28 out of 121. And that doesn't simplify either. But now if we wanted to keep it, so let's choose one of those tiles. So we had 7 that were worth 1 point. But now let's say I chose that A. That's the one I selected randomly. Now I have 10 options, but still 4 of them that are worth 2 points or more. So this becomes 28 out of 110, and that one does simplify to 14 out of 55. So you can see how side by side these look very similar, but you do have to look at these key words, whether you're putting it back or keeping it. So if you're putting it back, it's independent and your denominators are not going to change. But if you're keeping it, your denominators are going to change depending on how many items you end up keeping. In all these cases, we ended up keeping just one tile, but if you chose to keep, for instance, 3 of them, then that changes things too. Okay?